1.7 inverse trig functions. First, let's look what sine, cosine, and tangent all look like. So we didn't write everything out, but here's what our sine typically looks like. And it keeps on going. So even though I didn't try it, looks something like that. That was not very good. And it would keep on going over here. Our cosine looks something like this. So similar, but has a different starting and ending point. Oh, I did better on that one. But again, it would also go over here. Our tangent, well, this is where we have the asymptotes. So it looks something like this. But again, that would still repeat on and on and on forever. So this section is called inverses. Inverses means the opposite of, kind of like adding, subtracting, or inverses, multiplying, dividing, or inverses. If we wanted to see if this is a function, yes, we do our vertical line test. All of these are functions because it only goes through one spot. Then we want to see if the inverse has a function. That's our horizontal line test. And as you can see, when we do that horizontal line test, it goes through multiple points because this goes on forever. So our horizontal line test is showing us that it does not have an inverse. However, this is mathematics. We make it do it what we want. When we talk about inverse, again, this is kind of short. We are just going to be focusing on one certain part. So if we're looking at sine, it would be in between these 2 points. So like from here to here. So now if I'm saying this right here is my function, and if I do my horizontal line test, my hand was right in the middle. I'm sorry about that. I do my horizontal line test, that all works, okay? If I look at cosine, it's from here to here. So I didn't do that the best, but from this point to this point, right? From here to here. And again, if you do your horizontal line test here, those all work now. And for tangent, now if we look at our tangent, if we did a horizontal line test from here, it doesn't work. But we are just taking one of those pyramids. So right here, because again, if we do a horizontal line test, that works. So let's break this down. What does this actually mean? So this is going to be a good indicator to help you as we go on in this chapter. When we're talking the inverse of sine, our inverse of sine, our range is in between negative pi over 2 and pi over 2. Okay, so that means if it's in between negative pi over 2 and pi over 2, that's going to be in the first and fourth quadrant. That's where our inverse of sine can be. So that's saying if I locate it on my quadrant, it can be my first and fourth, because this is where the pi over 2 is, and this is where negative pi over 2 is. So it's right here in between those two. If I look at my inverse cosine, that's going to be in between 0 and pi, because again, 0 and pi, x and pi. So when we're talking about 0 and pi, we're talking about the first and the second quadrant. So if you're looking at my quadrant, here's 0, here's pi, so it can be either of these two. So inverse sine is going to be in the first or second. And if I look at my tangent, that's also going to be in my first and fourth. Because if you look right here, our ranges for both sine and tangent are the same. So negative pi over 2 and pi over 2. Now this is not a happy coincidence. It's just facts. If you notice, how would I tell the difference? How do I tell if which one is which? Well, we already know that cosine is even and sine and tangent are both odd. So if it's odd, you know that that function is going to be in the first or the fourth. If it's even, it's first or second. So let's get into some questions. So arc sine is just basically saying the same thing as the inverse. Arc sine and sine -1, those are like the same thing. So I could rewrite this because I'm looking for the angle that I'm talking about. So I'm looking for that right there. So if I'm going to be drawing this, sine is negative. And since we know sine is negative, it's going to be all sad. So we know sine is positive in these two. So we know sine is negative in these two. So if I wanted to, I could draw out my two triangles. But because we're talking about the inverse, and because we started with the inverse, we have to go back to, okay, sine inverse is only in the first and fourth quadrant. So it's not going to be this one. No, no, no. We're looking at this quadrant only. So this is the angle in which I'm looking at. So my opposite is -1. My hypotenuse is 2. So this is where you have to know your special right triangles. That means over here it's square root 3. And in the 30, 60, 90, that means this angle right here is 30 degrees. However, because I'm looking for the exact possible answer and I want your answer in radians, looking at this angle, we're looking at this angle right here. So in degrees, I could go 360 minus 30, and that's going to give me 330, and then I could change that into radians. Or if this angle's 30, that means I know for sure this fraction is going to have a 6 on bottom. And then I'm going to count. So this is where I would have pi over 6. That's 1 pi over 6. 2 pi over 6 can be simplified. 3 pi over 6 can be simplified. 4 pi over 6 can be simplified. 5 pi over 6, 6 pi over 6, 7, 8, 9, 10. This is going to be 11 pi over 6. If you're like, well, that didn't make any sense, ask me in class and I will explain it again. So this answer right here is 11 pi over 6. I know what you're thinking. You're like, wait, Miss Frickman, but that doesn't actually fit in our domain. So if we bring it back, so I found this angle, and again, this is kind of how your thinking process. I could actually find the negatives. We're moving from positive to negative. 11 pi over 6 is going to be the same thing as just negative pi over 6, this angle right here. So it's going to be either in between the negative pi over 2 or pi over 2. So this right here is my actual final answer. I want you to try to do the second one by yourself. Try to do the second one by yourself. Because this is positive, it's going to be in the first quadrant, because it's positive because quadrant 2 is not in the arc sign or inverse sign. So when I set up that special right triangle, my angle here is 60, and 60 is the same thing as pi over 3. So the last one, so again, this is saying that sine of some angles equal to 2. So if I did this, I know that this is going to be a no solution. Why is this no solution? Well, in order to do this, my domain, if you look back up here, my domain is negative infinity, or negative 1 to 1, negative 1 to 1. My tangent can be negative infinity to infinity. So this is not in my domain. Another way to think about this is when you rewrite it like this should always be less than 1. If this is not less than 1, then it can't be happening, or a negative 1. So same type of thing for cosine, arc cosine. So again, if I write this up, this is going to be cosine of something is equal to square root 2 over 2. This is where it's really beneficial if you remember how you rationalize your equations or your denominator. So this would be like 1 over square root 2 because we're dealing with special right triangles. So cosine right here is positive. So cosine even, so this is all sad turtles cry. If it's even, it's going to be in the first or fourth. But because this is arc cosine, it's either in the first or second. So that's how I know it's only in the first. Okay? Because the fact arc cosine is either in first or second, and because it's positive, it has to be in the first. So that means my adjacent here is 1, and this would be square root 2. So again, my special right triangle then here, in that special right triangle, this is 45. So that right there is going to be pi over 4, because that is in between 0 and pi, because cosine has to be between 0 and pi, 0 and pi, where sine and cotangent are in between negative infinity, or negative pi over 2 and pi over 2. So arc tan 0. So again, tan of something is equal to 0. So when I get 0 or 1, this is where it'd be beneficial when you know your tans is y over x. So this is kind of saying like this was 0 over a number. In this case, it was probably 1. So tangent again is in my first and fourth quadrant. So in between these two. So if I'm looking at 0, my y value as 0, and I'm looking in between my first and my fourth, this right here would be where y was 0. That point was 1, 0. So that angle right there is just 0. Because again, we have to be in between negative pi over 2 and pi over 2. Right now I want you to try to do C by yourself. So this is what your picture should look like. And again, I'm going in between negative pi over 2 and pi over 2. So this angle right here, when I have a 1, 1, and a square root 2, this is the angle 45. And the angle 45 in radians would be the same thing, negative 45, would be the same thing as negative pi over 4. So example 3 is using your calculator. Now, one thing about using my calculator, again, this is where you just have to be careful. You have to make sure you're in the correct mode. These are, if it does not say, this is going to be mode radians. So I'm going to go make sure my mode is in radian. It is. Great, grand, wonderful. To quit, I'm going to go second mode to quit. So now if I want arctan, that's the same as that -1 right there. So I go second tan. So that's my arctan of negative 8.45. Now, I want you to always round to the nearest 4 decimal spots. Well, that's going to be a 4. So this answer would be negative 1.4530. So now I want to pause the video and try to do B and C. Now, one thing, not to be rude, but your calculator is smarter than you. So let's say if I type this in, well, it's saying, no, this is a domain error because 2 is not in the domain. So it's saying 2 is not in the domain, so this would be a no solution right here. One thing you have to be very careful about when we're talking about the inverse sign when sign. It is not the same thing as you thinking about when I have multiply and divide. They're not complete opposite. They do not cancel each other out in this instance. When I'm dealing with these ratings, they do not cancel each other out. So this is not equal to, this will not be equal to 3 pi over 2, okay? So let's go into seeing what this is actually equal to. Actually, let's go to question 4a. Now, we do have the case that we can say if we have an arc, oh my gosh, spell arc right, arc, sign of a number that's in between negative pi over 2 or pi over 2. In this case, these two can cancel out. In this case, since it's in the domain, these two can cancel out. An example. So if we have tangent and arctangent, these two, because -5 is in the domain of arctan is negative infinity to infinity, this is going to be equal to -5. Here, 5 pi over 3 is not in our domain. However, I can figure out what coterminal angle is in our domain. So sine should be in between. So I'm going to subtract 2 pi from this because sine should be in between negative pi over 2 and pi over 2. This is equal to negative pi over 3 because this becomes a -6. So if I have arc sine of negative pi over 3, this is going to be equal to negative pi over 3. So let's say if you try to do this. Now notice how when I found that coterminal angle, this now is in the domain. It's in between negative pi over 2 and pi over 2. If I try to figure out the other angle here, if I subtracted 2 pi, that would give me a negative pi. Well, this is where you have to be careful. This was in our domain. Once I do that, I would get a negative pi, which would be a negative 3.14. Our domain is for sine and cosine as -1 to 1. So in this case, there would be a no solution because we cannot have a number that's greater than 1. So even if I had found the coterminal angle of this, it would not be in this domain. Okay, moving on to example 5. So first I'm looking at this right here. So I'm going to set up a right triangle. It says cosine, arc cosine. Here's my angle. Because if I wanted to, for that spot right there, I could go cosine of some angle. Oh my goodness. It's equal to 2 over 3. So adjacent over hypotenuse. This is where you have to figure out your third side. And because we can go bring it back to geometry, a squared plus b squared equals c squared, this would be 9 squared minus 4 squared, which would give 4 squared. That's a fun game, square root 5. Okay, so I'm completing my triangle. Now, since I have this, I'm talking about this same angle. This right here is this angle. Okay, now I'm saying tangent of this angle. So once I have that right triangle, this is the angle I'm looking at. So my tan here is going to be my opposite. So in this case, would be square root 5 over my adjacent, which would be 2. So this right here is my final answer. I want you to pause the video and try to do B by yourself. And you should have got 4/5. So you're like, how did you know it was in that quadrant? Well, remember, sine is either in first or fourth. First or fourth. It's negative, so I know it for sure is going to be the fourth. That's why I need to put in the fourth quadrant. So last but not least, what if I ask you for it in terms of x? Now, if you notice here, this first spot that I'm doing, so for both of these questions, this part right here is the same. So when I set up this triangle, it's going to be the same for both problems. So it's telling us our domain for x is right here. So it's saying that it has to be in between 0 and 1/3. How do we know that? Because of that period right there. Remember that 3, I would do 2 pi divided by 3. So that kind of changes things around. However, when I'm doing this, I can still think of it as normal. So I have cosine of an angle. That's what I'm looking at. So if I wanted to write this out, if cosine of an angle is 3x over 1. That means my adjacent is 3x. That means my hypotenuse is 1. And that means when I'm figuring out that third side, it's still a squared plus b squared equals c squared. So in this case, I would do 1 minus 3x squared and the square root of that. Okay, so this third side would be the square root of 1 minus 9x squared. Because I would take this squared and x squared. 3 squared is 9, and x squared is x squared. So now if I'm looking for the sine of this equation, now that I have my triangle, in terms of x, my sine is my opposite. So square root of 1 minus 9x squared over my hypotenuse. You don't have to have the 1 there, but you sure can if you want to. Right there would be my final answer for that. I want you to pause the video and try to do cotangent. Cotangent. You do not have to rationalize this denominator. Nope. So do the cotangent of this. And you should have gotten 3x over the square root of 1 minus 9x squared as my final answer, because adjacent over your opposite is your cotangent. Again, you do not have to rationalize that. That would be terrible of me to do that to you. Have a wonderful day.